So hello everyone and welcome to this session 1 of our online course on design and detailing of structural steel connections using Idea Statica, MS Excel and manual calculations. So this is the session 1 and I welcome you all to this session. So before we start, I hope my voice is audible and you can see the video also and you can see the presentation also. Are these three things uh, okay for all of you? So you can hear me, you can see me, and you can see the presentation also. All right. Good. Good morning. So I would like to begin by thanking all of you for joining this course with us. Uh, Many of you are past participants, but many are also joining a course with Oxen for the first time. So I begin by extending our thanks to those who have put their faith and effort and money with us. Okay, so I would like to assure that you will have a good time during this course. Okay, so before I begin, let me just inform you that the model that we adopt during our courses is that we keep all of you on mute. So you will not be able to unmute yourself. And the way to communicate would be by putting whatever you want to put in the chat box. So whatever is your doubt or any difficulty, you can just put it in the chat box and we will monitor it and reply to any problem that you have. Also, do not be hesitant to ask questions or do not be hesitant to raise queries or any doubts, because unless you do not have queries or do not have doubts, I mean, if any query or if any doubt remains unresolved, you will face difficulties later on. So do not feel hesitant to just ask whatever you want to ask. So we have a good number of participants and it's actually a good mix of participants. Many of the participants are practicing structural engineers. Many of them are professional consultants. Some of you are also in the government service. Some are faculty members. Almost all the participants are postgraduate uh, in civil engineering. Some of them are pursuing. So it's actually actually it is a good mix of engineers that we have. It's after a long time that we are conducting a short-term course, because last year in 2022 we were busy in conducting some month-long. Sorry, we were busy in conducting some long structural design center programs for the participants, for the structural engineers. So last year, for about 4 months, 5 months, we conducted RCC Structural Design Center program, and for the next 6 months, we conducted a steel uh, Structural Design Center program. So it's almost after a year that we are starting with the online short-term course. So before I move ahead, whatever we have to write, we will be writing on this whiteboard. So if you can see this whiteboard, I'll be writing on this. So I hope you can see this also. So any writing, any calculations, whatever we have to do will be done over here. Is this visible? So this is the whiteboard feature that we have on the Zoom platform. I hope this whiteboard is visible to all of you. Yes, good. So to those who will be watching these sessions later uh, on our portal, because many of the participants will not be able to watch the live sessions and they will be watching them on the platform later on. So all the sessions will be uploaded on the platform. I'll inform about the process, how the sessions are going to be uploaded, and then you can watch it as per your convenience. If you want to watch it live, then you have to join the daily session at 8:30 a.m. If you want to do both, that is, if you want to watch it live as well as if you want to watch the session once again on the portal, that also you can do. So any option you want to do, any option you want to pursue or use is available. There is no problem with it. So let us begin then, and let us start by a small presentation that we have made today. So this will be the first and last presentation. Otherwise, we will just be doing calculations and all those things. So yes, one more thing, we would encourage you to make written notes, because we will not be providing any written notes to the participants. So it is requested that you sit with a pen, a notebook, and a calculator. So we are going to do a lot of calculations. So it is important that you have a scientific calculator with you, and please sit with a pen and a notebook to just note down whatever you want to note down, because then if we do not note, we tend to forget it, what we had discussed. So this is another instruction that I just want to give you. Okay then, so let me start. And before we start, why are connections not discussed for RCC structures? So why, let us start with this first question, that why are connections not discussed for the RCC structures? Why do we discuss connections only for steel structures? Why not for RCC? We may discuss connections, we discuss connections for precast, but we do not discuss connections for RCC structures. So why is it so? Why don't we discuss connections for RCC, and why do we discuss them only for the steel structures? Anyone? You can just type in the chat box and whatever your answer if you want to give. So in RCC, when I say RCC, I am mostly talking about the cast in situ type of structures. So in cast in situ, what happens is that they are cast in situ, they are monolithic, construction. So monolithic means they are casted together. Even if they are not casted together, they are assumed to be as good as a monolithic structure. For example, if I have to talk about a beam column portal, let's say this is my column, and this is my column. I'm showing an elevation over here. This is my beam. This is my beam. So generally, what is the sequence of casting? What will be the sequence of casting generally? If this is an RCC column and this is an RCC beam, how do we cast it? What is the sequence? So the sequence is that we will cast, let's say, up to usually the practice is to cast it till the beam bottom, right? And then this portion is cast later. So even though this is not strictly monolithic, it's not monolithic because you still have a joint over here and here, but the reinforcement that we provide it in such a way that it is as good as a monolithic construction, correct? Hello. So therefore, we don't talk about the connections in RCC structures. There is no talk of connections in any of the RCC structure that you have, that you might have studied till now. So then why do we discuss connections in, let's say, steel structures? Why do we have to discuss connections in steel structures? So in steel structures, sorry, why do we have to discuss connections for steel structures? Because in steel we have, yes, tell me. So in steel we have dissimilar, heterogeneous, different elements that we have to join, correct? Hello. So in steel structures, what do we have? We have uh, different, dissimilar, and heterogeneous elements that we have to join. Let's say I have shown you over here three elements, three different elements. Let's assume it to be the elevation right now. So this is the, for example, this is a column, this is a column, and this is a beam. So I have to join these three together, and wherever I have to join them, I will have to join them using what? Yes, I will have to join them using. So if this is 1, this is 2, and this is 3. So I have to join them using a connection. Okay. Is my voice audible? Hello. I hope my voice is audible. Yes. So we have to join them using connections, these three heterogeneous elements. Similarly, if we are going to rest it, let's say on an RCC pedestal. So if this is my RCC pedestal, if this is my RCC pedestal, over here also I have to provide certain connection. Okay. So here also I have to provide a connection, and here also I have to provide a connection. So you will notice that there are two families of connections that we are providing. Between 1 and 2, both were steel elements. But because they were different elements, I had to connect them using connection. Also between 2 and 3, both were steel, but I had to provide a connection for them. But over here between this 3 and RCC, and between 1 and RCC, what was the difference? That one, this was steel and this was RCC pedestal. So these were two different materials altogether. Over here also I had to provide a connection. Similarly, this member number 3 was a steel. Again, it was supported by a RCC pedestal. So over here also I had to provide a connection. So in steel structures, you understand why connections have to be provided, because steel structures are heterogeneous, they are different, and there is nothing like cast in situ in them. If you have studied about precast, has anyone worked on or studied about precast RCC? Yes, anyone in the audience who has done any design on precast or has used precast for any of their structures or has studied precast? Precast RCC I'm talking about. So when we discuss about precast RCC, over here also we have to understand about the connections. Okay. Over here also we have to understand about the connections because of the different dissimilar elements that we have to join in precast. Okay. So connections become not relevant in RCC, but in steel structures we have to discuss about connections. So this was the first point I just wanted to clarify. I just wanted to discuss. Then before we start, another point is that member design. I had asked this question earlier also. I had put it on the LinkedIn also a few days ago. So according to you, member design or connection design, which should come first? So it's like the chicken and the egg problem. Which should come first? Member design or connection design? So Mr. Girish is saying member design should come first. Yes, anyone? So we have only one person saying that member design should come first. Okay. Mr. Sunil Kumar is also saying member design should come first. Alek, who is joining from Nepal, he is also saying member design should come first. So Rajenji is saying, considering connection, we should go for member design. Yes, this is an interesting point. Okay, so see, member, why are we designing connections? Why are we designing connections? It's important to understand that why are we designing a certain connection? So we are designing a certain connection for the based on the member forces, right? So we are designing the connection design is as per, I hope you agree, is as per the member forces. So for understanding that a particular connection has to be designed for how much force, you need to have the member forces first. And how will you get the member forces? So you will have to run an analysis, and from there you will have to get member forces. Also your connections, also your connections have to be designed for a particular member size. Okay. For example, if I have a hollow section, if I'm using hollow sections in my column and hollow sections in my beam, the connection type will be different. If I am using a I section for my beam and I section for my column, the connection type will be different. So connection design is to be done as per the member forces, and it also depends on the member type. So in a way, member design has to be done first, and then connection design will follow. Okay. Member design has to be done first, and then the connection design follows later. Having said that, there is a parallel view also that sometimes in some situations you have to decide what type of connection you have to decide what type of connection type you will be providing. Okay, so connection type may have to be decided first. In some cases it happens that you have to first understand and decide that what type of connection you will have to provide, and depending on your connection type you may have to choose the member, or you may have to rework your member design. It happens rarely, but it may happen. Also, as Vijay Kumar is saying that based on the connection rigidity. Yes, this is an important point that we will be discussing in this course, that based on the connection rigidity, you may have to vary the member size. So connection in that case may have to be designed, I mean, you don't have to design the entire connection, but at least you have to understand what type of connection you have to provide, and then you will be designing your member. So in that case, it will be slightly a reverse process, that you have to first decide what type of connection you will be providing, and then you have to work on the member. So this reverse happens not often. The general sequence of events is that first we finalize our member, and then we do the connection design. Okay, but in some cases we may have to go in the reverse direction also. That means the connection has to be decided first, the connection type has to be decided first, the strategy for connection design has to be formulated first, and then we will go for the member design. So it's actually a mixed answer that I would give, that member design or connection design, which comes first. Mostly member design will come first, followed by connection design. But in some cases, it will be the reverse scenario also. I had put this post on LinkedIn also a few days back. In most of the textbooks on steel structures, for some reason, you will always see that they start with connection design, right? In most of the steel structural books, textbooks I'm talking about, you will see that they start by, I mean, they simply start by doing connections first. I have never understood why. And then they later on go to the member design. So actually that creates quite a lot of confusion when we read the textbooks. When I studied steel design for the first time in the college, it was very confusing for me to learn connection designs first, and then learn the member designing. Then I think towards the end of the subject, I I understood why connections were taught or where they were taught. Because if in lecture one, suddenly the professor comes and starts by discussing bolts and welds and discusses rigid connection, pin connection, you don't understand. So in textbook syllabus, it becomes quite confusing when connection design is taught before the member design. If you look at the code IS800 2007, you will see that connection design is covered in which section? Yes, anyone remembers? Connection design is covered in which section? So connection design is covered in section number, anyone? Section number 10. Okay. So section 10 covers the connection design. And if you see section numbers 6 to 9, I'm talking about IS800 2007. So section 6 to section 9, they mainly cover the member design. Okay. So in IS code, they have covered the member design first, followed by connection design later. Anyway, so I hope you understand. So in most of the cases, if I could just conclude this discussion, in most of the cases, member design need to come first, and then you need to follow it up by the connection design. But in some scenarios, you may have to work out what type of connection is possible or what type of connection you will provide. And then you may have to think about the member. But this is rare. Okay, good. So these were some points that I just wanted to discuss before we could start. Moving ahead. Why are structural steel connections important? Why we are doing an entire course on just structural steel connections. So let us discuss why structural steel connections become important. So if you look at the failures in structural steel, the most, and it has been, people have studied this in several studies, it has come out. If you see practical failures in structures, you quite often conclude that the most common reason for failure in steel structures is the failure of the connections. Okay, so improper connection failure is one of the most common reasons for failure in steel structure. Okay, have you seen or read about any structure, any steel structure failing, and where the failure was due to connections? Anyone? No. Okay. If I could give you a simple example, in most of the PEB sheds, if you see, so let's say this is my rafter. Mr. Asad is saying that in PEB, he had come across a failure where the failure was due to improper connections. So if this is my rafter, I'm giving a simple example. This is rafter, and let's say this is a purlin on top of the rafter, and then I have got a sheeting on top of it. So if you see in wind events, the most common failure is that the sheeting blows away, right? The sheeting just blows away due to the high wind pressure being exerted. In fact, it even happened in the Visakhapatnam airport, I think during 2016. There was a big cyclone in Visakhapatnam, 2016 or 18. I don't remember the year, but the airport sheeting had large parts of airport sheeting had blown away. So Hudhud, yeah, the cyclone was named as Hudhud cyclone. There is actually a naming format for the cyclones. So what had happened? The entire structure was standing strong enough. What had failed? the failure had happened at this connection level. So this connection between the sheeting and purlin had failed, right? Connection between sheeting and purlin had actually failed. So because of failing of this connection, this entire sheeting had just blown away. So if you see, it was a connection level failure. Otherwise, the entire structure was standing strong enough, but because this connection had blown away or failed, your entire sheeting was was uh, damaged, and large parts of it fell at a very great distance away from the airport. Anyway, so it was a connection level failure. Earlier, I don't know if you have seen, in the earlier times, they used to provide a J bolt. How many of you have seen J bolts being provided? So, for example, if you had a purlin, if you had a purlin like this, then they would provide a J bolt. So this is called as a J bolt because of the shape of it. So these J bolts were actually much more better option to tie down your sheeting. Okay. Because they would give you much better resistance. These days, what are provided? These days, what is provided? These days, what is the connection provided between the sheeting and the rafter? So it is called as, yes, it is called as self-tapping screws. Okay. They are generally called as self-tapping or self-driven screws. Okay. So these are not good enough. Actually, they do not even have large penetration. They just slightly go inside, and there is a very poor arrangement that is made. These self-tapping screws can never withstand your wind. Okay. So this is a connection level failure. This is a connection level failure. So why structural steel understanding structural steel connections become important? Because it is one of the most common reasons for failure in steel structures. And I just gave you a very simple example, but we have seen big structures collapsing, big structures failing due to failure at the connection level. Okay. So therefore, to understand uh, steel structures, it is very important to understand connections. A well-designed and detailed steel structure must have well-designed connections. Quite obvious. A structure, I would say a structure, a steel structure. If I write down, a steel structure is only as good as the connection. Correct? Is only as good as connection. So I often give this example. Let's say you must have seen this chain link example also. So let's say if this is my chain link, or this is my chain link, and let's say this has a capacity of 100 and this has a capacity of 50 and this has a capacity of 100. Now if I decide to pull it by some force, how much can this chain link bear? These unit numbers that I have written, let's say these are the force resistance capacities of individual link. Now if I decide to pull this chain link, at what force, what external force will this chain link break? Yes, what external force will this chain link break? So this chain link will break at any force more than 50. I hope you agree. Okay, so as soon as this crosses 50, you will see a failure happening in this particular link. This link will fail. Now, if I have to enhance the capacity, if I have to enhance the capacity of this chain as a whole, let's say instead of 200, if I make it as, instead of 100, if I make it as 200, will the capacity be enhanced? Will the capacity of this chain as a whole be enhanced? So of course it will not be enhanced, because still the failure happens at the weakest link, and the capacity of the weakest link is still 50. So what I want to tell you is that assume this is your member and this is your member. Now, let's say your member was quite well designed. You had done all the, you had followed all the steps, you had followed all the analysis processes, you had followed all the codal provisions, and you had provided a well-designed member. But your connection was not properly designed. So where will the failure happen? Where will the failure happen? So failure happens at the connection level. Is it understood? I hope, yeah, this is simple. So failure will happen at the connection level. Right. So if you want to enhance the performance, or if you want to enhance the capacity of this system as a whole, what do you have to do? You have to increase the capacity of this particular connection. Okay. So when you make it as 100, let's say, if you are able to enhance the capacity of this connection, and suppose if you are able to make it as 100, then you will be able to increase the overall resistance of this system. Do you understand? Hello? Yes, no? This is quite simple. Correct. So connection, a member, a steel structure that you design is only as good as the connection that you have provided. Is only as good as the connection provided. Most of the times we are able to design the members quite well. Member design, we are able to do it quite well, but connection design, we miss out, and we end up providing connections that are improperly designed, and affect the overall uh, they affect the overall stability, strength, and stiffness of your steel structure. So it's very important that for a well-designed and well-detailed steel structure, it must have a well-designed connection. Okay. Then, very important, the connections must confirm. This is not CONFIRM. This is CONFORM. So what does this mean? One is confirm, CONFIRM, and here I have written CONFORM. What is the difference between this? What is the meaning of this confirm, CONFIRM? So this means, for example, if you have to confirm the timing of a particular meeting to someone, or let's say you confirm that you will reach at 7:30 at some place, then you will write this confirm, CONFIRM. But what does this CONFORM confirm mean? So this means that it has to adhere to, or it has to follow, or it has to be in accordance with or comply with, right? So it has to be it has to comply with, or it has to be in accordance with, or it has to adhere to the synchronization between very important design assumption, modeling strategy. This is strategy. Put a T over here. Strategy and site execution possibilities. Very, very important. So what does this mean? Let us understand. Let's say that I will explain this by taking you to the whiteboard. What I'm saying that the connections have to conform to the sync between modeling, between design strategy. So I write over here design strategy and modeling assumption and site execution. So I have given this example earlier also, but let us repeat it once again. Are you able to see the whiteboard? Right. So let's take a case, and I tell you that we have, let us say this is my column. I'm drawing it in elevation, and uh, this is my another, sorry, this is, are you able to see which pen I choose, which color I choose? No, just wait. Right, so this is my column, let's say, and then I have a beam. It's a long span, okay? It's a long span, and let us say that because of the long span, there is a lot of deflection that I'm getting. So the problem is that I am getting a very large deflection because of the long span, and because right now my uh, connection type is, let's say, simply supported connection. So now if I have to control the deflection, this is the problem. I have to control the deflection. Okay. So what is the design strategy I will have to adopt? If I have to control the deflection in this, right now it's a simply supported situation. So therefore I'm getting a very large deflection in my beam. This is the beam. I hope you are able to understand. So if I have to control the deflection somehow, what is a strategy that I can adopt? All these are steel beams and steel columns. Yes, please. Strategy. So a strategy that I can adopt, as Rajenji is saying, is to provide a rigid connection over here instead. Do we all agree? Hello. So a strategy is to adopt a rigid connection. Yes or no? So when we provide a rigid connection, what happens? That the earlier deflection pattern that we were getting of a simply supported beam now changes to a rigidly connected beam. Okay. Are you all understanding? So the deflection naturally will go down. The deflection will go down. My moment diagram, which earlier I was getting a complete sagging moment diagram. Now, what type of diagram will I get? Earlier, what I was getting as a completely sagging moment diagram. Yeah, just pardon me for my poor drawing, but I hope you understand. So a complete sagging moment diagram now changes to what? Now it changes to a hogging sagging. Hello. Yes or no? If I decide to change to a rigid connection assembly, I hope I'm audible. Okay, so this was my design strategy. What was my design strategy? My design strategy was to adopt a rigid connection. Why did we have to adopt a rigid connection? Why did we adopt rigid connection? To control deflection. Okay, to control the deflection. So this was my design strategy. How will I execute it in my model? How will I execute it in my model? So in my model, actually, I will have to do nothing, because in all the analysis software that we use, whether it is STAD or ETABS or SAP 2000, whenever we join any member to member, let's say these are line elements. So whenever we join line elements to line elements, uh, by default, they are joined as what? So by default, they are joined as uh, rigid connections. Okay, they are joined as rigid members with each other. So in model, we will have to provide no release, and we have to model them as per the default setting in the software. So you just have to connect them. Do not provide any release. So this is the modeling assumption. And on the site, when we are going to provide, uh, we have to ensure that a connection is so provided, a connection is so provided that it is rigid enough and it is able to take the analysis end moments and analysis shear forces, and it is to be provided on site in the site execution, in the site detailing. It has to be ensured that the connection is rigid enough, it is able to take the analysis moments and shears. Okay, very important. So you have to work out your connection in such a way that it is rigid enough, it is able to take the necessary moments and shears. Do you understand these three aspects? So your design strategy, what was your design strategy? To provide rigid connections. Why did you want to provide rigid connections? Because you wanted to control the deflection. Then in the model, analysis model, whether you are making it on STAD or ETABS, what did you have to do? You have to ensure that no releases were provided. And then during the site execution, before even site execution, during the connection design and detailing, I should write it over here. So during the connection design and detailing, you have to ensure that your connection is behaving rigid enough, is made rigid enough, is able to take the moments and shears. Do we get this much? Hello? Yes, no. Now, where does the problem occur? The problem occurs when there is, when you fail to have a sync between these three. So let's say design strategy, modeling assumptions, and site detailing, and I will say connection design and site detailing. So where does the problem occur? Let's say you decided that you have to have rigid connections. Okay, you decided that you will have to, you not need to provide rigid connection. You even made your model in such a way that there were no releases. But when while designing the connection and let's say while providing it on site, you provided a connection which was not rigid enough, or it was not able to resist the end moments. Do you understand? So let's say I provided a cleat connection like this. Are you with me so far? So I ended up providing a connection of this type. So my design strategy was to have a rigid connection. I made a proper model also, but when designing the connection and when going for the site detailing, I provided a cleat connection like this, which does not behave rigid enough. So what will happen? That your bending moment diagram that you had assumed will be something like this, a sagging hogging shape for a perfectly rigid connection. This may turn out to be something like this, that the hogging moment will decrease at the ends and the sagging moments will go up. Do you understand? If this connection is not rigid enough, hello, if this connection turns out to be not rigid enough, what will happen? Are you able to get it? That the hogging moment that you had assumed, that you had expected at the ends will decrease and the sagging moments at the midspan will increase. Correct? So in turn, it will lead to a larger deflection than you had anticipated. And why this is happening? Because of a connection that was not designed according to the strategy. Are you with me so far? Hello. We will discuss this issue in greater detail during our later sessions also. But do you get it? Hello. Okay. What else can go wrong? So let's say you provided a good connection, you provided a very rigid connection, but in your modeling assumption, what you did that by mistake, you provided the end releases. Okay. So your design strategy was to develop rigid connection. You uh, made a proper looking rigid connection. You made a proper looking rigid connection, but in your model, what did you ended up doing? Let's say you ended up providing releases. So again, it was out of sync. Again, it was out of sync. So what I'm trying to explain over here, that it's very important that the connections conform to the sync between design assumption or design strategy, the modeling, and site execution and detailing that you will do. In most of the practical structural projects, in most of the structural steel design projects, this synergy or this sync is not maintained. And the main reason is due to the connections. The main reason is due to connections. Do you get it? I will give you another example. Another example can be that in most of the uh, portal frames, again, I'm drawing an elevation. Uh, what is the assumption that how the lateral load will be resisted? If this is an elevation of the portal frame, the green members are beams, red members are columns, and this is a portal frame. Portal frame means it is a rigidly connected geometry. So what is the assumption for load resistance? Let's say if I asked you that how is lateral load resisted? So lateral load is resisted by the development of end moments. Do we agree? So if I could draw a diagram, a rough looking diagram for a lateral load, it will be something like this. Hello. Okay. So how is the lateral load being resisted? It is being resisted by the development of moments at these connection level, at these connections. So we uh, assume that these are rigidly connected members, and because of their rigid connections, they undergo a small amount of lateral sway also. I hope we agree. They will undergo a small amount of lateral sway. Okay. So now what happens if this assumption is not replicated in your connection design? So you had assumed a rigid connection, and because of this rigid connection, you had said that my frame will not undergo a large lateral sway and my lateral sway will be controlled. But if this connection turns out to be not rigid enough, what will happen? Yes, tell me. Hello. So your design strategy was to provide rigidly connected portal frame type of a system to control the lateral sways. That was your design strategy. You did the modeling accordingly. Accordingly, you found out the member sizes. But when you went for the connection design and detailing, your connections were not rigid enough. So what will happen? Hello. So what happens is that your sway will increase or decrease if your connection is not rigid enough? So sway will increase, of course. Sway will increase as compared to the assumed or expected sway. Do we agree? Sway will increase, of course. Right. So this is another example of what happens if your connections do not conform to the sync between your design model and actual detailing and fabrication. Very important. In most of the structures, this happens. In most of the structures where you see portal frames being used without the use of bracings, this is a common problem. This is a common problem that your structures undergo excessive sways because your connections are not properly designed. Rajenji is saying and fixed support will experience more movement. Right. So because these were not able to take, the movements will transfer to the support at the bottom. Even your bottom support, you had assumed a certain level of fixity, but if your bottom support is not able to provide a certain level of fixity, again, it will lead to increased sways, correct? Right. So very important that this sync is maintained. I hope you have understood what I wanted to say. We spent significant time on discussing this point, but I think you have understood. Very important point whenever we think about connection design. Okay. So another reason why structural steel connections are very important. Then moving ahead, I think we have covered this point that it is important that the connections are designed in such a way that they are able to transfer the member forces and are able to impart the required stiffness. Important. So not only member forces, but as I think who was saying it earlier, Vijay Kumar was saying it earlier. Yeah. So, so not only the member should be adequate, sorry, not only the connection should be adequate to transfer the member forces, but they should also be able to impart the required stiffness or assumed stiffness. I just gave you this example that you had assumed rigid connection, but if your member is not rigid enough, sorry, if your connection is not rigid enough, then it is a problem. So this also has to be ensured, and therefore the connection design also becomes very, very important. We will be stressing on this point about the stiffness that a connection will provide. Quite often this point is ignored, and mostly in IS800, actually it's not covered properly that how much stiffness is your connection providing, and it's not covered quite well. It's covered, but not quite well in IS800 2007. So when we will be using our software, we will be actually covering this point. And in the software, the stiffness calculations for connection is actually done as per the Euro code. So we will be using the Euro code for that. Okay. Do we get it? This we will be doing during our course in the later sessions. So not only your member should be able to transfer the forces, but it should be able to impart the adequate assumed stiffness. So very important point. Therefore, connection design becomes very important for us to understand. What is the next point? There are practically limitless connection types possible. Okay. Practically speaking, if you think about it, there are limitless connection types possible. Why? Because it will depend on the member used. For example, if you're using a I section, the so if your column is I section, beam is I section, maybe your connection type is different. If you have, let's say, a hollow section column, hollow section beam, your connection type is different. If you're using a circular pipe, your connection type may be different. It may happen that you are using a hollow section for the column and an I section for the beam. So again, the connection type becomes different. Are you getting it? So there are practically limitless possibilities when it comes to the connection types. I hope this point is clear. Hello. Okay. So it depends on the member used. It also depends on the design requirement. Design requirement means, as I just explained, that you want a rigid connection to be developed, or you want a pin connection to be developed, or you want a shear connection to be developed. So depending on the design requirement, your connection types change. Depending on the project requirement. Project requirement means some projects, or depending, let's say, on the construction practices, your connection type may change. How it may change? So for example, in most of the PEB structures, I don't know if you have seen the working of PEB. What they do is that they, let us say this is my column. I am showing you an elevational view. So most of the PEB installations, they prefer installation like this. Are you able to get it? So first, let's say they will erect the columns, and then they will put the beams over the top of the columns. It actually gives up an active support. So they prefer this type of installation. So this is the project requirement. So if this is the project requirement, the connection has to be provided over here. The connection has to be provided over here. Do you get it? Yes, no? Right. If, let us say, you were designing, or the project requirement was such that you were going to install this beam in this way. If this was your project requirement, that you are going to install your beam like this, are you getting it? To on the face of the column, then the connection will be provided over here. So do you think this connection A and B, which will be same or different? What do you think? I hope you are able to imagine. This is my steel column. This is the elevation. This is my steel beam, and this is column. So this connection type A and connection type B, of course, they will be different. So this is what I mean. So the the member forces may remain the same. So same member forces over here also, same member forces over here also, same member force to be transferred in the column also. But because of my project requirement, because of my installation requirement, erection and fabrication requirement, uh, there can be these two possibilities. Do you get it? So the connection design, when we are going to design the connection, if someone is designing this connection A, it will be different than this connection B. Right? Right. So this is what I mean by uh, connection depending on the project requirement. I hope you get it. Or you can say site requirement also, or project requirement also. I hope you get it. Okay. By the way, which is better in your view? Which of these two is a better connection, A or B? Hello, A or B, which is better? Many of you are saying A. Why A is better? Asad is saying B. A, easy to erect for A. Yes, A is actually easy to erect, and also because A provides an active support of the column. Okay, A is providing your beam and active support. Active support means, let's say, even if the connection does not perform well, or uh, it malfunctions, still your beam will continue to get support of the column. At least vertical support it will get. Let's say it will not get the it will not get the rotational support, but at least the vertical support it will continue to get. Okay. But if you look at this connection B, it is completely dependent on the connection, right? If you look at this connection B between the beam and column, this connection is completely dependent on the working of this connection B. So if your connection B malperforms or it does not perform efficiently, then there is going to be a direct failure over here. Okay. In this connection A, even though it will not be able to transfer the moments, if my connection malperforms, still it at least gives a vertical support, right? So A is more preferable in my view as compared to the connection B. It's also easy to install. It's also easy to install. In connection type B, what you will have to do, so you'll have to keep on your beam lifted by some arrangement, and then in the lifted condition, you will have to put this connection. Okay, so it's much easy to install the connection A. Rajenji is asking, is connection a shear connection? No, actually you can develop this connection also as a moment connection. Even this connection assembly like this can be developed as a moment connection. Yes. Okay. So what I was trying to make a point over here, that there are limitless possibilities uh, for your connections, depending on the member used, depending on the design requirement, depending on the project requirement, depending on the installation requirement. So therefore, we cannot discuss. Mr. Venkatesh is asking how we raise further on A. Raise further on A means? Raise further on A. Next floor. Oh, okay. He's saying what? Okay, okay. Understood. His question is that what do we do if we had a multi-story construction? No, so if we have a multi-story construction, we will not go for this type of a connection. Here I was just talking about some PV shed installations that we do, where we only have a roof floor to attach. So if we have a multi-story, it will be difficult it will be difficult, not impossible, it will be difficult to go for this connection A. But I have seen structures where they do this also, and then they put on the next floor column, but then they will put over here they will put some stiffeners. They have to do a lot of jugaad in that case. So if you have a multi-story construction, then you will prefer the connection type B. But here I was talking mainly about a industrial shed type of connections. Okay. Is it understood? Okay. All right. Okay. Yes. So because of the limitless possibilities, can we discuss, or is it will it be possible to discuss all the connections? Can we really, or can anyone discuss all the possible connections? Can we ever discuss that? Hello. Can we discuss all the possible connections? What do you think? So we cannot discuss all the possible connections because there are limitless possibilities. Okay. So therefore, it is important for us to understand the approach that we have to keep in mind while doing the design and detailing of any connection. So during this course, what we are going to do, that we are also going to uh, discuss about the approach that needs to be followed. Practically, it will not be possible to discuss the connections, all the possible connections, because they are just limitless. So as I said, during this course, we will be trying to form an approach for the design and detailing. So these were just few points which I thought we should list down, discussing why structural steel connections are important. Any other point anyone wants to add? Any other point anyone wants to add, that in their view, why structural steel connections are important? These are some points that came to my mind, so I have put it over here. But in addition to this, any other point? No, very good. Mr. Salman is saying he sees that connection which is done by fabricator without design is very bad, which does not follow standard, but it stands on site. Yeah, so it will stand on site. Why will it fall? Because they, even if it is being done by fabricator, they still have some understanding, or they have some thumb rules that they follow, right? And then there are a lot of safeties that are, that you already have. Generally, your connections are not stressed to their max limits. So even a badly done connection stands pretty well on site. That does not mean that we provide ill-designed connections. No. Mr. Vijay Kumar is saying welding connection is not discussed. Could you please share any if you have time? No, we will be discussing welding connections. We will be discussing welding connections in the course. Mr. Asad is saying progressive collapse if connections are not properly done, and progressive collapse may lead to the structural collapse. Right. So what I was telling in the first point, that most of the common failures in steel structure is due to failure of connections. And when connections fail, generally they fail without giving you sufficient warning. And mostly in steel structures, they lead to what is called as a progressive collapse. Okay. So progressive collapse means that, let's say, uh, if you have got a multi-story structure, and let's say if this connection here fails, then this, let's say this level falls, this level falls on this, then this level together falls on this, and so on. Progressive collapse. Uh, okay, so moving ahead, these are some of the important reasons why structural steel connections need to be carefully studied and understood. So quickly moving ahead, what are the methods for, okay, all the general questions that are being asked, we will take it in the end. You can just put it in the chat box. We will take it towards the end. Okay, what are the methods for connection design? Because in this course, we will be doing the connection design. So what method should be followed? Yes. So because we have understood now that connection design is important, let us discuss that what is a method that should be followed uh, for connection design. Yes, to the audience, those who, if I could ask that what is the design method they follow for connection designs? Okay, so because the possibilities are limitless, because the connections possible are limitless, we cannot have a well laid out algorithmic method. Do you understand what is the meaning of well laid out algorithmic method? So well laid out algorithmic method means that you follow A, then you go to step B, you go to step C, you go to step D, you go to step E, and at then you finish. Okay, this is what I mean by a well-defined algorithmic method, step by step. So because you have so many connection types possible, you cannot always have a well laid out step-by-step approach, but you will have to suitably work out your way for the connection that you are going to do or design. So mostly the practicing consultants or the design offices or engineers, they use different methods for connection design, right? You might have seen that, let's say for member design, if you work in some office or if you do any project, for member design, generally people use some software. So there they have a well laid out process that how they will do the member design. But for connection design, they don't have a well laid out process. Every consultant, every design office usually follow a different process for doing the connections, right? I hope you will agree with this. So some people will just do some manual calculations. So they rely only on some quick hand calculations. In other offices or with other structural engineers, you will see that they use, let's say, some Excel spreadsheets. Some others use some software. Okay, softwares that are available in the market. For example, softwares like RAM connection or software like Idea Statica or any other software they will use for connection design. So different people use different methods for connection design. There cannot be a well laid out process because of the large variations in the connection types possible. So what is the approach that we are going to use? Okay, how many of you are do the manual calculations for connections? Those who are into steel structures. So Mr. Asad is saying he uses the manual plus use of software. Okay. Anshul is saying he uses manual calculations for connections. Mr. Girish is saying he uses Excel sheets for connections. Good. So I think these three approaches are being used. Also, one more problem is that some people go by the IS800 code. Some people, I don't know, they will use some AISC documents. Some people go for the Euro code for design. So there are this variation also that is possible. So Salman is saying for complex connection, software is better. Anyway, so these are the approaches that you often see in the companies that where I have worked, where we and my wife Akanksha we had worked. They used to actually go for the spreadsheets. So they had some predefined spreadsheets. So you had to put in the values, you got the result, and accordingly you had to provide the detail. Uh, Many of the connections, I also do it by manual calculations. Some connections, I do it using the software. So I also, or in our office also, we use all the three approaches. Asad is asking which is more preferable as per your experience. See, if you are going to do repeated connections, let's say, if you have to do a repeated sort of connection. By repeated sort of connection, I mean that let's say you have to do a cleat connection. This is a cleat connection. Okay, this is my beam and this is a column. And I have to develop a beam to column shear connection by providing a web cleat. So if this is a connection and all this beam is also an I section, this column is also an I section, and let's say I have to do 100 such connection designs. Okay, if I have to do 100 such connection design, I understand the behavior of this connection, I understand the working, I understand the manual calculations behind it. So if I have to do this repeated job, then I will do it using what? Then out of these three approaches, which approach will be a better approach? The question is understood, right? I have a cleat connection to design uh, between an I section beam and an I section column, and it's a well understood connection. I quite well understand the behavior of this cleat connection, but I have to do 100 such uh, connections in a big project. So then I will rely on some Excel spreadsheet, right? So I will make an Excel spreadsheet myself, and I will first verify it, and upon verification, upon uh, assurance that the Excel sheet is working fine, I will use my Excel sheet for doing the connection. So for repeated work, for connection types that are repeated and that are well understood, we can use some Excel spreadsheets. For some connection which is, let's say, which you don't use quite often or which you don't come across quite often, you may have to rely on some manual calculations, and you may have to rely on some software for understanding the behavior and for getting some initial results. So it depends uh, on the type of connection that you are doing, that which approach you will follow. Okay, right. Anshul is saying he prefers to do the manual calculation because I remember capacity now after preparing a lot of sheets. Okay, so Anshul is saying that because he does a lot of hand calculations, he actually now I mean, he has developed a mental database that what connection, how much shear will it take, or what connection will take how much moment, that sort of a thing, right? Mr. Alek is saying for built-up column section to ISMC with ISMB beam. Yeah, so for these types of connections, you may have to go for some uh, use of software or for some manual calculations. See, Excel spreadsheets, when is Excel spreadsheet, when is using an Excel spreadsheet advantageous? You cannot make an Excel spreadsheet for all the connection types, right? So when is this of advantage? When is using an Excel spreadsheet of advantage for you? When you are going to do a repeated work, correct? So if you are going to do some repeated work, then using Excel spreadsheets is of advantage. All right. You cannot prepare an Excel spreadsheet every time you come up with some connection type, because developing an Excel spreadsheet takes time. It requires effort. And let's say if you are going to do only one such connection, it may not be worthwhile to develop a complete Excel spreadsheet for it. So developing spreadsheets is of advantage when you have to do a repeated work. Let's say if you are an engineer in some PEB company. In PEB company, they have standardized connections, right? In pre-engineered building companies, they have some standardized connection types. Standardized connections. So standardized connections means they have predefined that this is the connection that we are going to provide. Only the beam size and the column size may change, and the forces and moments will change. Otherwise, the connection type is standardized. So for these types of connections, developing spreadsheets makes sense. Are you getting it? Yes. So for repeated work, Excel spreadsheets are good. But if you come across a connection that may not be repeated in your other projects, it may not be worthwhile to develop. spreadsheets. In some of our courses, in one of the earlier courses where we had done a course on PEB structures, we had developed Excel spreadsheets because in PEB structures, I'm talking more about the industrial shed type structures. The connections are mostly standardized by the manufacturer. So we had developed Excel spreadsheets on the basis of that. Okay. Yes, we will develop, we will share those Excel spreadsheets. How many of you are able to work on Excel? How many of you are able to work on Excel? No one. Are okay. Many of you know the workings of Excel. Very good. Good. So we will be developing some Excel spreadsheets also during our course. Okay, so these are the common methods that we have for connection design. So what is the approach we are going to use? Salman is asking for confirmation or self-confidence. We can cross-check manual with software. Yeah, we will be doing that. We will be doing that. So which approach are we going to use during this course? So during the course, we are going to have a mix approach. So firstly, we'll be starting with part to whole. Part to whole means first we will be understanding uh, first we will be understanding the connecting elements. What are the two basic connecting elements? What are the two basic connecting elements? So the two basic connecting elements that you see are bolts and welds, correct? So either you have bolts or you have welds. Do you have rivets? So rivets are only in the textbooks. Okay, rivets are only in the textbooks. Yeah, it's not used in any of the structure these days. You only have bolts and rivets. So we will start by understanding the bolts and rivets. Sorry, what am I saying? Rivets are no longer used. They are only used in the textbooks. Uh, the two connecting elements that we will be discussing will be bolts and welds. So the approach would be to first understand these two basic connecting elements, and the understanding will include understanding their behavior, understanding the methods of load resistance and the capacity calculation. So if you understand, let's say for a bolt, what are the type of bolts used, what is the capacity of bolt in shear, what is the capacity of bolt in tension, you will understand the workings of bolts, right? Similarly, if you are able to understand the types of weld, if you are able to understand the specification of weld, if you are able to calculate the capacity of weld in shear, uh, you will be able to understand the working of weld. So this is what we will first discuss. This is the first approach, not first approach. This is the first thing that we will be discussing. And this is the approach we'll follow of going from part to whole. Okay. So once we understand this, then we will do by this we will follow with doing manual calculations for the commonly used connection types. What we are discussing, remember, we are discussing the approach that we are going to follow in this course for our connection designs. I told you there are several methods possible in the last slide. Now here I am discussing the approach that we are going to follow in our course. So first we will understand about the welds and the bolts. Then we will follow it up with understanding the manual calculations for the commonly used connection types. So unless we do hand calculations, things do not become clear. So we will begin by doing some simple manual calculations. Okay. Then after doing manual calculations for the repeated connection types or for the connection types which are quite often used, we will ease the process and automate the process by developing some Excel sheets. So as I told that Excel spreadsheets, it's not convenient to develop Excel spreadsheet for each and every connection, but we will do it for the connections which are commonly used. Okay. So for commonly used types, we will develop Excel spreadsheets. This will automate our process and ease the process. And we will verify and cross-check our Excel sheet with the manual calculation. So that will give us a good confidence. This is what we will do. Next, we will discuss the connection design and detailing using software. So here we are going to use Idea Statica software for our discussions. So Idea Statica is a component-based FEM software. They call it as the CBFEM. So this software we will use this software for design of simple as well as complex connections and for design development of various connection typologies. And we will do a lot of things using the software. We will do a lot of things which may not be able to do using manual calculations. We will do them using the software. So it will be an interesting discussions that we will have by the use of software. So, and finally, let me just put, okay. So this is the three-pronged approach that we are going to adopt, just like people do it in design offices, or just like people do in their consultancy work, that there cannot be one size fits all type of approach. We have to pick and choose. So sometimes we'll be doing manual calculations. Sometimes we'll be relying on some Excel spreadsheets that we will develop, or we will be going for software. So it will be a mixed approach that we will also follow, because when it comes to connection, you cannot have a algorithmic systematic approach. But we will discuss in a way that even if you come across a difficult connection in future, you will be able to do it by adopting this approach. So this is what we are going to do in the course. So we will be starting with the from part to whole. That is what we are going to do. Okay, quickly just reviewing the course contents. Even though we had discussed it in the introductory session, but still once again going through it quickly, that we will be starting with the connecting elements. As I just said, we'll be starting with bolts, type and grade of bolts, capacity calculations, use of bolts in connections. Then we will go to the next connecting element, that is weld. Then one by one we will start discussing the connection families. So we will start with the beam to beam connection. Then we will go to the bracing connections. Then we will go to the beam to column connections. Oh, where is beam to column? I think that text has gone. Just wait. Okay, I think one item is missing over here. So we will go to beam, and after beam to beam connection family, we will go to, let me just write it over here because I think the text is missing. We'll go to the beam to column connections. Okay. There will be a lot of interesting discussions we will be having in the beam to column connections. So beam to beam followed by beam to column, then bracing connections, splicing connections. Then we will be discussing the anchor fasteners. I think some of the participants had suggested that anchor fasteners should be added. So therefore we have added anchor fasteners. Then we will discuss the column base plate connections. And then we will have some discussions on the uh, design and detailing of ductile connections, or how to ensure ductility in the connections. So that we will also be discussing. So these are the things that we are going to discuss. I had already put it during the introductory session, and also we had taken this up, or we have included in the course brochure also. So these are going to be the course contents. I just thought that once again we will put it over here in the first session, and all these discussions we will be having for different member types. So not only for I sections, but if let's say you have a hollow section, or if you have a built up section, okay, if you have a built up section, or if you have a circular section, or if you have some hot rolled sections, for all the for all these different member types, we will be discussing the above connections. Do you understand? So for example, if I have to do a column base plate fixed connection, if I have a I section, my connection will look slightly different. If I have a circular section, my connection will look slightly different. If I have a hollow section, built up section, my connection will look slightly different. So families, all these above families that I just discussed, we will be doing it for different member types. So therefore, we have written over here the members for all above mentioned connections will include, but not limited to, 3 plate sections. That means we will be discussing these, but if there is any other section type you want us to discuss, we will discuss that also. So 3 plate sections, hot rolled, channels, angles, square, rectangular, circular hollows, or any other built up types that you want us to, I mean, we will be taking up these members and we will be discussing their connections. But if you want to if you want us to take up any other section type, that also we will do. Also during this course, our special focus will be to discuss the connections that are commonly adopted in your projects. Okay. So the connection typologies adopted in the actual structural steel projects, we will be taking them up so that it becomes easy for you to use this knowledge for your practical projects. What are the standards that we are going to refer? Mainly we'll be relying on IS800 2007 because it is the Indian standard that almost all of us are expected to follow. But we will also be discussing some things using the AISC 360 because in IS800 there are some deficiencies, and we will also be relying on the Euro code. Okay. Okay. But main focus will remain on the Indian standard, but we will refer to as and when required to the American code and to the Euro code. What else? Yes, just one instruction to those who will be watching the sessions later online, or to those who are attending the session live, but they also want to review the session once again online. Uh, all of you have been added to this portal. How many of you were able to access the portal online? The instructions were shared through messages or emails. So I hope you were able to access this portal online. So you will see such a window and you will see this particular course added. Hello. Are you able to see it this way? Yes. If you have taken courses with us in the past also, you will see multiple courses over here. Okay. But one of them would be this particular course. Sometimes it happens that by mistake, the course goes to this archived tab. So just click on this archived and check whether this course has gone to the archive tab or not. By mistake, sometimes the participant clicks on this and sends the course in the archive tab. So just check that also. It should be in this active tab over here. So you will see this, and when you click over here, you will get this type of a window, which we are showing in the next slide. You will get this type of a window. So every day, every session will be uploaded over here. Okay. So for example, the session one, today's session will be uploaded over here. Then next session will be uploaded over and so on. So whatever you want to, whichever session you want to watch, you have to just click on the session and then you will be able to watch it in the screen. So this is the way to watch the sessions online. So yeah, this is what I had to tell you in our session one. So mainly, what did we discuss today? We discussed that why the connection design is important. What are the approaches for the connection design and which approach we are going to follow. All these things we discussed in the session today. So from tomorrow, we are going to start with the first thing that will be the as I said, we will be going from part to whole. So we will be starting our discussion with the connecting elements. Okay. And the connecting elements will be bolts and welds. So this is what we are going to start with, starting from tomorrow. So this is what I had to tell you in this session one. Now we will just take up your questions and queries. So I'll just go to the chat box and I'll see for the questions. If there are any unanswered questions, you can just put it in the chat box once again. So I'm just going back and seeing. Vijay Kumar is saying welding connection is not discussed. Could you please share if you have any time? No, we will be discussing welding connections in detail. Salman is asking in PV structure what weld, whether weld connection valid or not. See, every connection, it will be a mix of welding and bolted. We'll be discussing it tomorrow, but every connection that you see on site is actually a hybrid connection made out of weld and bolting. But when it comes to validity, of course, it is valid. There's nothing like not being valid. Mr. Vijay Kumar is asking, is welding connection rigid? Shall we go for shear connections with weld? Again, as I explained, in site, in actual projects, there's nothing like only welded connection or only bolted connection. Mostly it is going to be a mix of welding and bolting. Mr. Venkatesh is asking, how do we achieve strong column, weak beam concept in practice in steel structures if all joints are rigid? No, joints can be rigid. See, you are getting confused with two things. Joints can be rigid, but still you can develop, still you can develop a system where the beam is not as strong as the not as strong as the column. You can develop this, still the connection can remain rigid. If, for example, if this is my column in elevation, okay, and this is my beam in again in elevation, and the moment capacity of this beam is, let's say, 100 kilonewton meter. This is the moment capacity. The moment capacity of this column is, let's say, 160 kilonewton meter. So have you achieved the strong column, weak beam theory over here? You have achieved. You have achieved it in practical terms, the strong column, weak beam concept. But you can still make this as a rigid connection. What is the harm? Are you getting this? Right. So we can develop rigid connections uh, even though we might be following the strong column, weak beam concept. Then Mr. Venkatesh is asking what type of connection do we consider for residential buildings and for other types of buildings? This is a very general question. You have to be more specific. Then Asad is putting a comment that contractor guys are not letting clients for use of consultant design connections and members in PV structure in India. They have their own standards. Yeah, that happens because many of them just form a cartel and they will impose their own ideas on the client and on the consultant. Yeah, that can happen. Mr. Salman is asking, in current market, what purpose we can use rivet connections? We don't use rivet connections anymore. Mr. Alek, he is joining us from Nepal. He is saying that in Nepal they use mostly built-up columns and they mostly use built-up columns. So will we be doing that type of connections? Yes, we will be doing. Rajenji is asking, do IITs accept Idea Statica design during vetting? Maybe it is possible that professors are not aware of this Idea Statica software. Yes, the professors actually are not aware of a lot of issues when it comes to the IIT professors. Mostly they rely on their master's students or their PhD students. So professors themselves, I have not seen professors in IITs who are good at practical design. There are very few. There are very few. So mostly they rely on the PG students or PhD students for doing the vetting or the design work. Mr. Venkatesh is asking, can we design lifting hook connection in Idea Statica? I have never tried and I don't think there is any such option available. Mr. Vijay Kumar is saying, are all codes and profiles available in this software? Mostly, yes. Mostly all the commonly used codes, international codes, and the profiles are available in the software. And there are options to create your own profile also. So if you want to have any customized profile, that also you can do in the software. Okay. Any other question? Hello. Okay. So then I think we stop over here. I hope today's discussion was understood. And tomorrow we will continue with our session 2. And we will start with the connecting elements. So we'll start with welding and bolting. Dripta is asking, is RAM connection a good software for connections? And Asad is also having a similar question. Can we have a chance to compare RAM connection and Idea Statica, advantages and disadvantages? Yeah, unfortunately, I don't know how to work on RAM connections. So, I mean, that is a slight hindrance for me. But let me see if I can work on it and present a comparison towards the end. How many of you work on RAM connections? Okay, Mr. Asad works on RAM connection. Okay, uh, I'll try to work on it, and maybe towards the end, if possible, we can have a we can present a comparison between RAM connection and Idea Statica. I felt Idea Statica to be very good looking and a very clean looking software with a very good interface and some very really, I would say, important options available in Idea Statica. Yeah, Mr. Asad is saying Idea Statica is better available in the commercial market. Okay, it's actually good looking also. It looks good. The visual interface is quite good and very clean, and it offers you several options that are important for the structural engineers. So personally, I thought Idea Statica is a good software. Yes, here I must thank Rajen ji. Is Rajen ji online or has he left? Okay, he is there in the audience. So I must thank Rajen ji over here. He is a senior engineer in the government department in Rajasthan. So he is a regular participant in our courses before also. So he was the one who actually started using Idea Statica long ago, and he encouraged us to start working on Idea Statica. And I think he has done a lot of work on Idea Statica, comparing between the manual calculations and the outputs of Idea Statica. So he was the one who insisted and encouraged us to start using Idea Statica. So because of his encouragement, we also explored options of Idea Statica. We started working on the software. So I must thank him for his encouragement. Yes. Okay, so I think that's all we have for today. And tomorrow we will meet again and we will start with the connecting elements. Okay, good. Bye bye. So I hope everyone had a good session one. If there are any difficulties, you can just put it on the chat box or you can put it on the WhatsApp group. Okay, that's all. Bye bye.